In this lecture, we will focus on matrices. The idea of a matrix was introduced by Arthur Kelly in 1885. Now, what is a matrix? A matrix is the array of elements organized along horizontal and vertical lines. Let's suppose we have a list of numbers. We have organized the list of numbers along horizontal and vertical lines. Now enclosed this arrangement in a square bracket. This arrangement is called a matrix. A matrix is generally denoted by capital alphabets such as A, B, C, X, Y, and Z. In this arrangement, the horizontal line made by the elements is called row. This is row number 1. This is row number 2. And the vertical line made by the elements is called column. This is column number 1. This is column number 2. This is column number 3. The arrangement is called a matrix. A matrix is generally denoted by capital alphabets, such as we denote this arrangement by a capital alphabet A. Now in this matrix we have 2 rows and we have 3 columns. So the number of rows in matrix A is 2 and number of columns in matrix A is 3. Let's take another example. 5. Let's denote it by B. In this matrix we have 1 row and we have 3 columns. Now each matrix has its own order. Order of a matrix is defined as row cross column. Let's we have a matrix 1 2 4 -5 0 1. The order of A is has in this matrix we have 2 rows, we have 3 columns, so 2 cross 3 is the order of A. Let's take another example. In this matrix we have 1 row and 1 column, so the order of this matrix is 1 cross 1. C is another matrix which has the entities 1 0 0 0 1 0 0 0 1. Now what's the order of C? Order of C is, in C we have 3 rows and we have 3 columns, so the order of C is 3 cross 3. Now let's discuss the general form of a matrix. A matrix of the form A is equal to Aij is called the general form of a matrix. In this matrix, A represent element. A is an element of matrix A, and Ij represents I represent ith row, J represents jth column. So A represent element ij indicates the position of the number. Position of the number. For example, A 30, 31, A 31. A 31 means that this this element is in a third row and first column. So A represent element of the matrix and 3 1 represent the position of the element. Now let's expand this matrix. Number 1, for I is equal to 1 and j is equal to 1. If we have a matrix in which we have one row and one column, this implies that A will be A11. Number 2, if a matrix has two rows in which two rows 1 2 and two columns, then this general matrix implies A11, first row first column, first row second column, second row first column, second row second column. Number 3, if a matrix has three rows 1 2 3 and three columns 1 2 3, this implies that A will be first row first column, first row second column, first row third column, second row first column, second row second column, second row third column, third row first column, third row second column, third row third column. Now let's talk about the types of matrices. Now before we denote the number of rows in a matrix by M and number of columns in the matrix by N. Now what is a row matrix? If a matrix has order equal to 1 cross n, this means that if a matrix has single row and any number of columns, then the matrix will be a row matrix. Let's say the matrix A11, A12, A13 up to A1n. This matrix has single row and n columns, so this matrix is a row matrix. A is a row matrix. Number 2, column matrix. Column matrix, if a matrix has order m cross 1, this means that if a matrix has a single column and any number of rows, then the matrix will be a column matrix. For example, the matrix A11, A21, A31 up to AM1. Now in this matrix we have a single column and m rows. So this matrix is a column matrix. Let's denote the matrix by B. Number 3, rectangular matrix. If the number of rows and number of columns are not equal, then the matrix will be rectangular matrix. For example, the matrix 1, 2, 3, -1, 0, 1. In this matrix we have two rows, so the value of m is 2, and we have three columns, so the value of n is 3. Here m is not equal to n, so this matrix is a rectangular matrix. So C is a rectangular matrix. A matrix will be a rectangular matrix if the number of rows is not equal to the number of columns. Now type number 4. Now Hayes opposed to rectangular form in which the number of rows and columns were not equal. If the number of rows and number of columns are equal, then the matrix is called a square matrix. For example, a matrix 1, 2, 3, 4. In this matrix we have two rows, so the value of m is 2. We have two columns, so the value of column n is 2. Since they are both equal, so m is equal to n, so this matrix is a square matrix. Let's give the name, so D is a square matrix. Type number 5, diagonal matrix. What is a diagonal matrix? A matrix now in this matrix, this is the main diagonal. This is the main matrix will be a diagonal matrix if all the elements below and above the main diagonal are 0, except one non-zero element along the main diagonal. For example, the matrix B 1 0 0 0 1 0 0 0 0. This is a diagonal matrix because all the elements below and above the main diagonal are 0. So this is a diagonal matrix. This is also a diagonal matrix because one non-zero element is present along the main diagonal. But the matrix this is not a diagonal matrix because all the elements along the diagonal are 0. Type number 6, scalar matrix. Scalar matrix is the type of a diagonal matrix. In scalar matrix, let's say we have a matrix. This is a diagonal matrix. Diagonal matrix because all the elements are 0 except the main diagonal elements. Now if all the elements along the main diagonal are equal, then the matrix is called a scalar matrix. For example, B is equal to 2 0 0 0 2 0 0 0 2. This is a scalar matrix. First of all, it is a diagonal matrix because all the elements below and above the main diagonal are 0 and the main diagonal element are equal, therefore it is a scalar matrix. Number 7, unit matrix. Unit matrix is also the type of a scalar matrix, but all the elements along the diagonal will be 1. Now a type of scalar matrix in which the elements along the main diagonal are 1, then this type of matrix is called a unit matrix.